Alright, so this video will be about velocity vectors. We talked a little bit about this in class, but I wanted to give you a video just kind of explaining a little bit more in detail, maybe giving you some practice problems, etc. So velocity vectors, as the name says, only works with velocity. You don't really use speed vectors because a vector, which is an arrow, like that, will indicate not only the speed, but also the direction, and therefore it's used with velocity. So how these work is usually one of two ways. Either the arrow will be labeled with a speed, so we could say 10 meters per second, or the way that it would work is, let's say that I give you a legend, a key, and I say, okay, an arrow of this size, let's say 1 inch, is equal to 10 meters per second. So then I give you an arrow here. Let's say that this is a 2-inch arrow. How fast would that velocity vector be representing? I'll give you a second to think about that. If 1 inch is 10 meters per second, and this is a 2-inch arrow, it should be 20 meters per second. So on a quiz or test, you could see a velocity vector that looks like this, where I give you the actual velocity, or it could look something more like this, where I give you the key, and then you are responsible for multiplying out 2 inches, 2 times 10, 20. Either one could show up. So now let's do a practice 1 or 2. I'm going to erase this stuff. We're going to do the more complicated way just in case that shows up on a test. So let's say, we'll keep it simple, we'll say 1 inch, which is what this arrow here represents, equals 10 meters per second. That way it's just in nice multiples of 10. So let's say you have a short arrow that is 1 inch, and then you've got a long arrow. We'll say this is, it's obviously not drawn to scale, but we'll say it's 5 inches. This one is the wind, and this, let's say, is your plane. So the question would be, how fast, meaning what is the velocity, the resultant velocity, that's a good word, meaning as a result of this equation here, how fast does the plane end up moving, right? Because it's got a tailwind of a 1-inch velocity vector. So the first step in doing this is you need to actually put these inches into numbers. So 1 inch we already know is 10 meters per second, so that we could rewrite as 10 meters per second. 5 inches we can rewrite as 50 meters per second. So since the wind is going in the same direction as the plane, the resultant velocity would be a 6-inch vector, or we could say 60 meters per second. Either one would be a perfectly fine answer. Let's try this again in a little bit different way. Let's say we'll just always say the short one is going to be the wind, and the long one is the plane or the car or whatever's moving. So we've this time got a 2-inch wind, that's a fast wind, and we've got an airplane that's going this way. Let's say it's 10 inches. Okay, so now we've got a headwind. That means a wind that is heading into your face, slowing you down. So in this case, you would subtract. 2 inches will be 20 meters per second. 10 inches will be 10 times 10 meters per second, so 100 meters per second. Since it's a headwind, it's heading right into your face, you would subtract. So 100 minus 20 is 80 meters per second. That's the resultant velocity of that plane since it's heading into a headwind. The final option for what you could see is, the plane is moving this way. Let's say it's moving at, it's a 20-inch vector, and then we've got a wind, a crosswind. It's going like this. Let's just say it's, again, let's say it's 1 inch. That's fine, however many inches. In this case, I don't need you to be able to calculate exactly how fast the resultant velocity of the plane will be. That's a little bit more complicated. We don't need to do that right now, but what I would like you to be able to do is explain what ends up happening with this plane. Where does it end up going? How does it end up looking? And this should remind you of when we were talking about the Earth going around the sun. When the Earth goes around the sun, it gets pulled in all the time by the sun's gravity. And while the sun is heading off or while the Earth rather is heading off at a 90-degree angle, it's getting pulled also by the sun. So it results in a 45-degree angle. So what we can see here is that it's going to head off somewhere in that direction. And that would be the explanation that you'd want to give, that because the two forces, the two velocities here are heading in different directions, it results in some kind of off 45, 30-ish degree angle, depending on what these two speeds are. So a great way to practice these, and really you would be practicing either option 1 or option 2, is you can make your own vectors here. And rather than having it 1 and 5, you could do 10 and 6, or 2 and 20, and just practice doing the math and making sure that everything makes sense here. As always, please send me an email if you've got any questions.